This video includes theoretical notes of chapter complex numbers made from Punjab textbooks and aligned with Akueb student learning outcomes that will help you obtain more marks in exam. In case of any queries, comment or email at thenotesplatform@gmail.com. Complex numbers grade 11. The numbers of the form x plus iota y, where x and y belong to real numbers and iota equal to square root of -1, are called complex numbers. Every real number is a complex number with 0 as its imaginary part. Square root -1 does not belong to set of real numbers. It is called imaginary number iota. Square roots of negative quantities are expressed as multiples of iota. Square root of 9 is 3, but square root of -9 will be 3 iota. The real and imaginary parts of a complex number are treated separately for addition and subtraction but can be divided and multiplied. Iota raised to power 1 is iota itself. Iota raised to power 2 is -1. Iota raised to power 3 is negative iota. Iota raised to power 4 is 1. This pattern repeats for every 4 powers of iota. Iota raised to power 5 is iota itself. Iota raised to power 6 is -1. Iota raised to power 7 is negative iota. Iota raised to power 8 is 1. 1 is a multiplicative identity. 1 raised to any power n gives 1. However, -1 raised to any even power gives 1 and any odd power gives -1. 5 plus 0 iota is purely real. It has no imaginary part. 0 plus 5 iota is purely imaginary. It has no real number. If we add or multiply a complex number with its conjugate, we get a real number. A conjugate of a complex number is another complex number that has the same real part as the original complex number and imaginary part has the same magnitude but opposite sign. Original complex number 2 plus 3 iota. Its conjugate will be 2 minus 3 iota. To find conjugate, just reverse the sign of the imaginary part. A real number is self-conjugate. A real number such as 34 plus 0 iota will have the same conjugate because even if we change the sign of imaginary part and make it 34 minus 0 iota, it will have no effect overall, so a real number is self-conjugate. Take a look at the properties of conjugates of complex numbers. They are more likely to be assessed in multiple choice questions. Z is a complex number. Number 1, the modulus of Z is equal to the modulus of Z conjugate. Modulus depends on the magnitude and not the sign of the number. Even if the sign is changed in conjugate, the magnitude is still the same and both will yield the same modulus. Number 2, if Z is purely real, then Z is equal to Z conjugate. This property states that a real number is self-conjugate. Number 3, if Z is purely imaginary, then Z is equal to negative of Z conjugate. Number 4, conjugate of Z conjugate is equal to Z, which is the original complex number. Number 5, modulus of Z will always be greater than 0. Number 6, you will get the same answer if you calculate the modulus of Z raised to any power n or calculate the modulus of Z then raise it to power n. Number 7, modulus of Z is equal to the modulus of negative Z is equal to the modulus of Z conjugate is equal to the modulus of negative Z conjugate. Number 8, dividing Z1 and Z2 then taking its conjugate or taking conjugates of Z1 and Z2 first then dividing those conjugates, both will give the same result. Number 9, multiplying Z1 and Z2 then taking its conjugate or taking conjugates of Z1 and Z2 first then multiplying those conjugates, both will give the same result. Number 10, adding Z1 and Z2 then taking its conjugate or taking conjugates of Z1 and Z2 first then adding those conjugates, both will give the same result. Number 11, subtracting Z1 and Z2 then taking its conjugate or taking conjugates of Z1 and Z2 first then subtracting those conjugates, both will give the same result. Number 12, the modulus of sum of Z1 and Z2 will always be less than or equal to sum of their individual moduluses. Number 13, Z multiplied by Z conjugate is equal to square of modulus of Z. Rearranging the equation. Modulus of Z is equal to square root of product of Z and Z conjugate. Two complex numbers are equal if their real and imaginary parts are same. A plus b iota is equal to c plus d iota if a equals to b and c equals to d. X squared equal to 1 is an imaginary number because no real number can satisfy this equation. Every real number is a complex number, but every complex number is not a real number. Real number is proper subset of complex number. If a and b equals to 0, then z equal to 0 plus 0 iota is called complex number 0. The additive inverse of a number is its opposite number that is added to the original number to make the sum 0. If a number is added to its additive inverse, the sum of both the numbers becomes 0. When sum of two real numbers is 0, then each real number is said to be the additive inverse of each other. 5 plus negative 5 equals 0, so 5 and negative 5 are additive inverse of each other. To find additive inverse, change the sign of the number or multiply the number by negative 1. Z equals to x plus iota y. Additive inverse of z is negative z equals to minus x minus iota y. Adding z and negative z will give 0, as both are additive inverse of each other. If z equals to negative 6 plus 2 iota, then its additive inverse will be negative z is equal to positive 6 minus 2 iota. The multiplicative inverse is defined as the reciprocal of a given number. A number when multiplied to its multiplicative inverse results in 1. To find multiplicative inverse, take reciprocal of the number. Z multiplied by its reciprocal 1 upon z equals to 1. Z multiplied by z inverse is equal to 1. Z inverse means the reciprocal of z, that is 1 upon z. Z inverse of 0 does not exist, as 1 divided by 0 is infinity. Z inverse of 1 is 1, as 1 divided by 1 is 1. Absolute value or modulus of z equals a plus iota b is equal to square root of a square plus b square. Z is a comma b, which means z is equal to a plus iota b. If z would be a comma b, then it would be equal to negative a plus iota b. Z1 is a plus iota b and z2 is c plus iota d. Addition of complex numbers. Z1 plus Z2 equals to sum of real numbers and sum of imaginary numbers. Z1 minus Z2 equals to sum of difference of real numbers and difference of imaginary numbers. Product of Z1 and Z2 a plus iota b multiplied by c plus iota d. First is multiplied to the other complex number, then iota b is multiplied to the other complex number. AC plus AD iota plus CB iota plus BD iota square. Iota square is equal to negative 1, so AC plus AD iota plus CB iota minus BD. AC minus BD plus AD plus BC with iota. Complex number multiplied to a scalar number k. K multiplied to a plus b iota is equal to k times a plus k times b iota. Factorization of algebraic equation of form x squared plus y squared is x plus iota y multiplied by x minus iota y. For example, 9x squared plus 16y squared is equal to 3x plus 4y iota and 3x minus 4y iota. Factorization of algebraic equation of form x cubed minus 3x squared plus x plus 5 is equal to x plus 1, x minus 2 minus iota, x minus 2 plus iota. In this equation, the highest power of x is 3, so it has 3 factors, whereas in the previous equation x had highest power 2, so it had 2 factors. Also remember the standard quadratic equation, which also has highest power 2. Ax squared plus bx plus c equals to 0, whereas not equal to 0. If a would be 0, that means the entire first term would be 0, and if x squared term is 0, that means the equation is not quadratic. Commutative law for addition is z1 plus z2 equals to z2 plus z1. Associative law for addition is that the answer is equal whether we add sum of z2 and z3 in z1 or we add sum of z1 and z2 in z3. Similarly, commutative law for multiplication is z1 multiplied by z2 is equal to z2 multiplied by z1. Associative law for multiplication is that the answer is same in both cases, product of z2 and z3 multiplied to z1 and product of z1 and z2 multiplied to z3. Distributive law states that Z1 is multiplied to the sum of Z2 and Z3 is equal to sum of product of Z1 and Z2 and product of Z2 and Z3. Division of two complex numbers will also give a complex number. Commutative and associative laws are not true for division of complex numbers.